90% of the world's rare earths pass through one country's tanks. This is the file on the step after the mine. In June of 2026, China placed 10 American companies on an export control list. 2 of the names on it, MP Materials and USA Rare Earth. The companies at the center of America's own attempt to build a rare earth industry that doesn't run through Beijing. It was the third such control round in 14 months. Within weeks, prices for some of the affected materials had spiked as much as 6-fold. For European firms, license approvals fell below 1 in 4. No blockade, no embargo announcement, paperwork. The materials in question are 17 metallic elements called rare earths. They are in the motor of every electric vehicle, the generator of most offshore wind turbines, and by one congressional estimate, roughly 900 pounds of them are in every F-35. One country processes about 90% of the world's supply. Here is the part that breaks the intuition. China holds only about a third of the world's rare earth reserves. The United States has its own giant deposit. Australia has more. This is the file on how a monopoly was built on the step after the mine. And the strangest detail in it, China's own supply of the most critical elements is trucked out of a war zone. We'll get there. Rare earths are the 15 lanthanides plus scandium and yttrium, 17 elements clustered at the bottom of the periodic table. The name is a 19th century accident. They are not rare. Cerium is more abundant in the Earth's crust than copper. What they almost never do is concentrate. Most deposits hold them smeared thin, all 17 tangled together, chemically so similar that telling them apart is one of the hardest separation problems in industrial chemistry. That is the detail this entire file turns on. The industry splits them in 2. Light rare earths, neodymium, praseodymium, are the muscle of the strongest permanent magnets ever made. Heavy rare earths, dysprosium, terbium, are scarcer, and they are the ingredient that lets those magnets survive heat. An electric motor at highway speed runs hot enough to kill an unprotected magnet. A few percent of dysprosium is the difference. Neodymium magnets are in the traction motor of most EVs, a kilogram or 2 per vehicle. A single large direct-drive offshore wind turbine can carry several tons of magnet. They are in hard drives, robot joints, precision-guided munitions, and the fin actuators of missiles. The magnet is small, cheap, and irreplaceable. A few dollars of material without which a $100,000 motor does not turn. The defense numbers are the reason this file exists. By Congressional Research Service estimates, an F-35 carries roughly 900 pounds of rare earth material. A Virginia-class submarine, closer to 9,000. Radar, sonar, electronic warfare, guidance. The magnet problem is not an electric vehicle problem with military implications. It is a military problem that happens to also price your car. From the 1960s to the 1990s, the center of the rare earth world was a single open pit in the Mojave Desert, Mountain Pass, California. It supplied most of the planet. Then, through the 90s, Chinese producers, with lower costs, looser environmental rules, and explicit state priority, undercut the market. Prices collapsed. In 2002, after a series of wastewater spills and with prices on the floor, Mountain Pass stopped mining. The West did not lose its deposit. It closed it. What China built was never just mines. Bayan Obo in Inner Mongolia became the largest rare earth operation on Earth, and the ionic clays of the southern hills around Ganzhou became the world's principal source of heavy rare earths. But the decisive investment was in the step after the mine: separation plants, refining capacity, metallurgy programs, and 2 generations of chemists and process engineers. A line often attributed to Deng Xiaoping from 1992 puts the intent plainly: the Middle East has oil. China has rare earths. Whether or not he said it exactly that way, the state built exactly that. Here is the mechanism, and it is the whole episode. Rare earth ore is nearly worthless as rock. To become a magnet, it must be cracked with acid, dissolved, and then separated, element from nearly identical element. Through solvent extraction, the mixture passed through mixer-settler tanks, hundreds of stages in sequence, each stage nudging the split a fraction further. Then the separated oxide must be reduced to metal, alloyed, and sintered into magnets. Mining is a hole and a truck. Separation is a chemical industry. Only one country built the industry at scale. Why didn't anyone else just build it? Because for 20 years, there was no reason to. Separation is capital-hungry, chemically filthy, and brutally low margin when Chinese supply is cheap. Every attempt to finance a Western plant ran into the same wall. The incumbent could drop prices below your business case and wait. Thorium-bearing waste and acid streams make permits slow in any Western jurisdiction. The moat is not geological. It is economic, environmental, and human. And it deepened every year nobody crossed it. So the market shares today look like this. Mining, China, around 2/3, significant, but with real competitors. Processing, roughly 90%. And for the heavy rare earths, the dysprosium and terbium that make magnets survive heat. Separation capacity is about 99% Chinese. There is exactly one significant non-Chinese separation operation, Lynas of Australia, refining in Malaysia. And for years, even Western material routinely made a round trip through China to become useful. Now the detail almost nobody says out loud: China's own heavy rare earth supply depends on imports. The ionic clay deposits of Kachin State in northern Myanmar, across the border from Yunnan, supply more than half of China's dysprosium and terbium feedstock. Imports rose from under 20,000 tons in 2021 to over 40,000 by 2023. Mining sites tripled after Myanmar's coup, in territory contested between the junta and the Kachin Independence Organization. The most strategically sensitive elements on the periodic table are trucked out of a war zone, processed in Ganzhou, and sold to the world as Chinese control. Beijing has known what this lever is worth since 2010. After a collision near the disputed Senkaku Islands, Japanese importers reported rare earth shipments from China abruptly stalling. Prices went vertical. Tokyo funded Lynas, industry engineered dysprosium out of what it could, and the WTO ruled China's export quotas illegal in 2014. China complied and rebuilt the same lever as licensing, which is harder to litigate. The embargo taught everyone the playbook, including its author. The current version is a doctrine. April 2025. 7 heavy rare earths put under export licensing, dysprosium and terbium included. October 2025. A second round. June 2026. Controls aimed at specific American companies. Each round is calibrated, enough to spike prices and stall Western factory lines, not enough to trigger a full decoupling. Defense magnet costs up as much as 500%, an estimated $500 of added cost per electric vehicle. And in February, 54 nations met in Washington for an emergency critical minerals ministerial. The clearest sign yet that everyone now reads this as the weapon it is. The American answer runs through the same pit in the Mojave. MP Materials restarted Mountain Pass mining in 2017, and for years shipped its concentrate to China for separation because there was nowhere else to send it. That is ending in stages. In July 2025, the Pentagon took a $400 million equity stake, the Department of Defense becoming a shareholder in a mine, with a 10-year magnet purchase guarantee. A heavy rare earth separation line at Mountain Pass began commissioning in mid-2026. Magnets are coming off a line in Fort Worth, with Apple contracted for recycled feedstock supply and a second plant targeted for 2028. But capacity is not the hard part. Time is. Industry estimates put meaningful Western processing independence 5 to 7 years out, and that clock only runs if prices stay high enough to keep the projects alive, which hands Beijing a precise dial, restrict enough to hurt, ease enough to starve the alternatives. Every pause in the controls is also a price signal aimed at the business case of every Western separation plant. Every other file in this series is about a place, a strait, a canal, a river. This one is about a choke point with no coordinates. You cannot sail around a knowledge monopoly. You cannot escort a solvent extraction cascade with a carrier group. 30 years of chemists, permits, price wars, and patience were compressed into a single sentence of leverage. Everything advanced runs on magnets, and the magnets run through one country's tanks. 3 ways this file ends. 1. The dial keeps working. Calibrated rounds, Western projects perpetually, 5 years from independence. 2. The rebuild holds. Mountain Pass, Linus, and their successors reach scale by the early 2030s, and the lever loses its teeth round by round. 3. The chemistry moves on. Magnet-free motor designs and recycling shrink the demand the chokehold stands on. The pit in the Mojave is the same pit it was in 1965. What changed, twice, is who was willing to do the step after the mine.